all of the applications basically stem from the ability to generate a world that just from a few words. You look at it and like, there's a world, that's generated in front of your eyes, and it's amazing that it's happening. I was very excited about how far can we push that.
And it's at the point where like a human who is not an expert, like will watch it and think it looks real, right? And I think that's pretty incredible.
Jack, Shlomi, Genie 3 has taken over the internet. We're honored to have you on the podcast today. Has the response surprised you? Reflect a little bit about the reaction.
We weren't sure like how big it's going to be, but we definitely felt, I felt definitely that we have something that was kind of like for a long time coming, basically being able to generate environments in real time. I think a lot of work that was done in Google DeepMind and outside pointed to that direction, but we really wanted to make it happen, and I hope we have. Yeah.
Team, why don't we reflect internally a little bit about what we found so game-changing about Genie 3 and why we're so excited to have this conversation? Mark?
Yeah, for sure. I mean, first of all, it's an amazing model. I think there's a lot of excitement around the spatial memory, the consistency across all the frames. I think this is the first time I can see like you can have some sort of interactive way of doing this stuff with videos, because it used to be like you would do one prompt and you would have like 15 seconds of a video, but now you can actually have some sort of interactive kind of element to it, which I think is very exciting. So can you elaborate a little bit more on like your insights on this? Like how was like, for example, figuring out what data you should collect, how you make it very interactive and keeping the flow of the whole video, which I thought was phenomenal.
Sure, yeah. So I think you kind of highlighted a few capabilities, sort of the length of the generation, the consistency of the worlds, maybe diversity as well of the kind of things you can generate. I think the main thing is that last year, obviously, we made progress in quite a few different fronts, right, in separate efforts, right? So we had this Genie 2 project that was much more sort of like 3D environments that it could generate. And it wasn't super high quality. It felt like it coming from Genie 1, but it wasn't the same quality as things like VO2, which the state-of-the-art video model at the time came out in December, roughly exactly the same time. It came out a week later than Genie 2. And obviously internally, there was a lot of like discussion between the two projects about the different directions we were pursuing. And then Shlomi had also worked on Game Engine, right, which is the Doom paper, as people know it, which I think you guys also wrote a nice piece on straight after that came out. So I think that also like attracted a lot of attention. And so that we felt that across these different projects, we had quite a lot of interesting things that would naturally kind of combine, and we could basically take the most like ambitious version of the combined project and see if it was possible. And fortunately it was, and quite I think the timeline is probably the bit that surprised many of us, because obviously we set ourselves these goals and like we tried very hard to achieve them, but you can never be totally sure how it's going to actually feel when you've got to that point. I think it ended up being something that resonated with people a lot more than maybe we expected, but we were always believers. So
yeah, I'll just add to this that I think the real-time component is really important. And people, not many people experience it firsthand, but we really tried in the release to at least have a few trusted testers interact with it and also get the feel of it by adding these overlays that show what happens, how people can use the keyboard to control it. And I think there is something magical about the real-time aspect. I felt it for the first time when our model, like the actually game engine model, started working fast enough, and we were just like, oh my god, I can actually walk around. And it was a bit of a wow moment. And yeah, I think there is something when it responds immediately that is really magical. I think that's kind of sparked the imagination of many people when the Doom kind of simulation came out, and here we really wanted to push it to somewhere we weren't sure it's going to work. So it was definitely at the edge of what's possible. I think that's how we felt. So we just said, yeah, let's try and see if we can make it happen.
I think you guys, like, I don't know if this was on purpose or not, but you perfectly timed it when everyone on like X and Reddit and everywhere was making those videos of like characters walking through games, but they obviously like weren't interactive, they weren't real time. And then you guys came out with this release that was like, now this is an actual product, and it blew folks away. I'm curious, because you can imagine so many different applications for this, right? Like more controllable video generation, or making it much easier to create games, even personal gaming where someone's just kind of creating their own world they walk through, like RL environments for agents, robotics. Like, are there any particular use cases that you're most excited about?
I think all of the applications basically stem from the ability to generate a world that just from a few words. And I think for me, kind of like this potential, when I started looking at video models, I think it was pretty early when I think it was one of the models were like Imagine Video, which was a model by Google Research. But there are a lot of models that kind of like, they were very basic compared to what we have today, but the ability to simulate something, like you look at it and like, there's a world, that's generated in front of your eyes, and it's amazing that it's happening. And I think at this point, I was very excited about how far can we push that, right? So I think VIA was one way to do it, and Genie is definitely another way to make it a bit more interactive. So I think all of the applications basically stem from these core capabilities. So it can be entertainment, of course, as you said. It can be training agents. It can be helping agents to reason about the world, education. So I don't think any particular application is more important or than others. I think it's really up to how developers in the future will build on top of that.
Yeah, I would give basically the same answer in the end with a different journey to get there, right? Which is, like, I personally myself worked in reinforcement learning for a few years before starting the Genie project in 2022. And the motivation originally was like that in RL at the time, we had this problem where we'd say, like, which environment should we try and solve, right? Because once you've already done Go, which people thought was years or decades away, and then that was solved in 2016, was solved, but we reached Superhuman level in 2016. And then StarCraft 3 years later, which is not particularly a long time for something incrementally significant. So towards 2021 time, it was a big question of what should we try and do with RL. We know that the algorithms can learn superhuman capabilities if they have the right environment, but we don't know what the environment should be. And so we were working on designing our own ones, right, with code. But then instead, it seemed like the more promising path when you had the first text to image models coming out. Whereas, like, what if we just think long term? What's the way to really unlock unlimited environments? That being said, over the course of the project, and originally we started it, I guess in 2022, it was very focused on that one application, but it seems quite clear now that this could have a big impact in all those other areas you mentioned, right? So I think it's like language models in 2021, maybe. You probably wouldn't have guessed like an IMO gold medal a few years later would come that fast. But as a direct application of that technology, right? It was probably, it can help me with my emails or whatever it was. And I think it's really cool to build these kind of new class of foundation models and then see what people can imagine doing with it. And that's one of the really exciting things about sharing the research preview, right? So you got this kind of feedback. So we're hoping a lot of these things can happen.
One of the things in the research preview post, Jack, that blew me away was this, and it wasn't even your first GIF, I think, in the blog post. It was either second or third. You had this visual of somebody painting the wall with the paintbrush, and then the character moves.
Yeah, the special
out
memory.
Of right, like out of to a different part of the wall, paints, and then moves back, and the original paint is still there. And I didn't believe it. I was like, "There's no way." Like, and then I read, and you're right. It's described as a special memory. So the persistence part for me, I mean, I'm not taking away from all the other stuff. The interactivity is amazing, but I think broadly speaking, folks expected that at some point, video generation, for example, would become real time. Like, when I saw the Genie 3 post, it was like, oh, okay, they actually went and did it. But the special memory, the persistence, was when I kind of sat up in my chair and I was like, how did that happen? Could you talk a little bit about when did you discover that as an emergent property, or was that a specific design goal? What's the backstory on that? Because that feels like a big unlock, Jack. Why don't we start with you?
Yeah, so that's a great question. I'll say a few things. So the TLDR is, it was totally planned for, but still incredibly surprising when it worked that well, right? So that specific sample, when I saw it, it was hard to believe. I actually wasn't sure that the model generating for a second. I was like, that it took me to watch it a few times and like really check and like freeze the frames and look back and check that it was the same. But so from go back a few steps. So obviously Genie 2 had some memory, right? So this got kind of lost because I mean, Genie 2 came at a time when there were lots of announcements, very exciting announcements. I mean, VO2 only a few days later. It was a busy time of the year. And the main headline act was that we could generate new worlds at all, right? So that was the thing that we wanted to emphasize. But it did have, a few seconds of memory. And we had a couple of examples, like I created a robot near a pyramid, looked away, looked back, and the pyramid's there. But it's like kind of blurry. It's not perfect. But some other models around the same time or more recently didn't have this feature, right? So people kind of indexed to that because they didn't notice the like early signs of it in the Genie 2 work. And then for Genie 3, we basically went much more ambitious on the same sort of approach, right? And we made it like a headline goal for ourselves is like, can we make the memory be what it is, right? We said we want minute plus memory and real time and this higher resolution all in the same model. And those are kind of conflicting objectives, right? So we set ourselves this kind of technical challenge and we said, like, if we target this, then it's just about feasible and it'll be pretty incredible. And then you still don't know, obviously, it's going to pan out. So then when you get to the end of the research, 7 months later, to see the samples, it still is quite mind-blowing, to be honest. So yeah, it's kind of planned for, but still pretty cool and exciting when you see it, because it's like, at the end of the day, research projects aren't like sure things, are they? So
one thing that we didn't want to do, and we didn't want to build an explicit representation, right? So there are definitely methods that are able to achieve consistency, and they did that through an explicit, some 3D, there are nerves and Gaussian splatting, and other methods that basically say, okay, if we know how the world looks like, we use this kind of like prior assumptions on how the world remains static pretty much, then we can build representation, and then what you're looking at. So that's great, I think, for some applications, but we didn't want to go down this path because we felt it's somewhat limiting. And I think, so we can definitely say that the model doesn't do that. And it does generate kind of like frame by frame. And we think this is really key for the generalization to actually work.
Every time someone interacts with it for the first time and they like test, they look away and then look back, I'm always like holding my breath. and then it looks back and it's the same. I'm like, whoa. It's still it's really cool.
It's very cool. And how long is this spatial memory? I don't know if you can talk about it. You mentioned a minute plus, but like, is there some sort of like measure that you have? Is it like, can you keep it for half an hour, or what is the limit on that?
There is no like fundamental limitation, but currently the current design we limited to 1 minute of this type of memories.
Yeah, it's also a real-time trade-off, I guess, as well. We felt that because of the breadth and the other capabilities, that like a minute was sufficient for for this version. Like, it's quite a significant leap, but obviously eventually you'd want to extend this.
One more question that related on between Genie 1 to, like, like for example, LLMs, like you have like DeepSeek R1, like they saw in this paper, like the longer they keep it running, they suddenly will see like these interesting behaviors, like the model will start like reasoning, or like would give like a oh, I'm wrong in this, I should self-correct. Do you see anything in kind of like this scaling from 2 to 3? Do you see any sort of like interesting behavior that you were not expecting that suddenly just appear by increasing the amount of data and the amount of compute?
Yeah, I'll just say I think there is a bit of like overall, definitely, like many generative models, we see that improvements happen with scale. I think that's not secret. And I don't know if we can, I don't think it's not the same type of intelligence, I would say, like an LLM has. Like, I'm not sure if reasoning is the right term, but we do see that some definitely things like it can infer from, if you approach like a door, it makes sense for the agents to maybe open it, so you might see that it's starting to do that, for example. Or there's some like better word understanding that happens over time, and it just like things look better and more realistic. So I think these are the trends that we've observed.
Yeah, and from Genie 2 to 3, it's like, I think the real world capabilities really increased, right? So on the physics side, some of the water simulations, you can see some of the lighting as well, like are really breathtaking. I think we have this example of the storm on the blog, and that one I think is super cool. And it's at the point where like a human who is not an expert like will watch it and think it looks real, right? And I think that's pretty incredible. Whereas with Genie 2, it was like, it kind of understands roughly what these things should do, but you know it's not real, right? You can look at it and you can clearly see that it's sort of not completely photorealistic. So I think that's quite a big leap on the quality in that side.
Yeah, one of the things that was really cool in all the examples was the water is sort of a great way to see, like, does it understand like what the world is and how objects interact? And that example someone posted of like the feet going in the puddle was amazing. But then there was also that example of like a cartoon character. It was more of like an animated style who was like running across this kind of green patch of land and then ran into this blue kind of wavy thing that looked like water, and he started swimming, which I thought was really interesting. Like, were there particular things you had to do around that for the model to be able to understand like how characters should interact in different environments and different styles?
What you're basically describing is like the real breadth of different kind of environment terrains and worlds and things like that, like water or walking on sand versus going downhill in snow, and how the agents' sort of interactions should differ given the like terrain that they're in. And I think that really is a property of scale and breadth of training. So this is very much like an emergent thing. I don't think there's anything like really specific we do for this, right? You again, like, you hope the model has learned this because it should have like a general world knowledge. It doesn't always work perfectly, but in general, it's pretty good. Like, so for the skiing examples, you do go fast when you go downhill, and then when you try and go back uphill, it's very slow, if not at all possible. When you go into water, obviously, you hope, as you said, that the agent will start swimming and splashing, and this does typically happen. When you look down near a puddle, hopefully you're wearing Wellington boots. Like, this kind of stuff does just kind of make sense. And I think it feels pretty magical because it very much aligns with what you were thinking about the world, and the model's just generated it all. So yeah, that's also one of the really exciting things for sure.
Yeah, and on top of that, one kind of trade-off that typically we have is that we want the model to do two things. We want the model to create the world in a way that looks consistent. So Jack said, like, if you walk in the rain or in puddles, then probably wearing boots. But if we provide it with a different description, or like the prompt is saying something else, we want it to still follow the prompt. And there is some tension here because some things are very unlikely, right? You might say, I want to wear flip-flops and jump in the rain or whatever. Then the model still has to try and create something that is very unlikely. And that's where typically, video models maybe find it more challenging. And that's where, our models might find it more challenging, but it's still successful to a surprising degree to go into this kind of like low probability areas. And I think that's really, in a way, that's what we want, right? Like, many people, they don't want to just look at the video that looks like their own, maybe this room, but more something a bit more exciting. And that's where, like, I think this is like magic of the models, that they can take you to places that maybe are not so likely to be in reality.
The text following is really amazing in this model, and that does feel really magical. I think there's something that the VO does really well as well, right? Like, pretty much what you ask for. It's really well aligned with text. And so, and we have that with Genie 3. So you could describe very specific worlds and really kind of like arbitrary, silly things, and it pretty much works. Like, we actually had this discussion because people were very disappointed to find out that the video I made of my dog actually was not my dog's photograph. I just described her in text. And yeah, I don't know if that's a big secret, but it looks exactly like her. And the model just kind of knows, right? I think that's pretty amazing. So I think that's actually a really important capability that we didn't have with Genie 2 as well, right? Because we relied on image prompting. And so there was some transfer issue, like, where you rely on Imagen to generate the image. And that often does look really good, but it's not necessarily a good image for starting the world. Whereas, like, going directly from text, you get the controllability of pretty much anything you want. Plus, it just kind of naturally works because it's in the like correct space for the model to do its thing. And that's something really powerful.
And why is that, Jack? What do you think led to such a massive instruction following a text adherence gain? Because it's a pretty hard thing to do.
Well, I mean, our team had never really worked on this. So Genie 1 and 2 both worked with image prompting. And so obviously, like for this next phase, we leverage a lot of the research done internally on other projects. And personnel-wise, I mean, Shlomi's obviously been co-leading the VO project. And so we were able to kind of build on a lot of other work and ideas internally. And that basically like allowed us to kind of like turbocharge progress, right? So if we'd done this sort of by incrementally building like ourselves on an island, it would have taken, I think, a lot longer than being part of Google DeepMind, where we have these teams that have a lot of knowledge in different areas that we can sort of lean and build on, which I think is super exciting about our being in this company right now, is that we have so many experts in different areas that we can like seek out advice and help from.
And Shlomi, a question for you on that is, having led the VO3 work, which is kind of mind-blowing, is there a reason why this is Genie 3 and not like VO3 real time?
So I think it's definitely a bit different, right? Like Genie allows you to navigate the environment and then maybe take actions, right? And that's not something that VO at this point can do. But there are other aspects that are different that Genie doesn't have, right? Genie doesn't have audio, for example.
Right.
So we just think it's while definitely there are potential similarities, it's sufficiently different. Also, another thing is that at this point, Genie 3 is not available, as a product, and we do think about it as like a product that is kind of like make mainstream and became very very popular, and what the future holds, I don't know. But I mean, at this point, we just felt it's sufficiently different in terms of what capabilities and how kind of like we think about this. So Genie 3 is pretty much a research preview, right? It's not something we are releasing at this point.
Something we think about a lot is what are the edges of a modality? We're talking about this all the time, which is, the lines start blurring pretty quickly between real-time image and video, and then real-time video and interactive, whatever, world generation, world model. I don't think we have a good word for what Genie 3 is yet, but you guys called it world model, which is, I think, a great term. But in your mind, like, where does the video generation modalities stop and real-time worlds start? And do you think in the future, are these converging into basically one modality? Or if you had to predict over the next few years, do you guys think actually, these will diverge into completely different disciplines? It seems like they share kind of one parent today, which is video generation. But where is the world going? Do you think, are these two completely different fields?
From my perspective, they're different. So I would say modality is one thing, right? We have text, we have audio. Even within audio, there are different type of sub-modalities. Speech is not the same as music. We have different products for music generation, and we have other models for speech generation, speech understanding. So even within one modality, you can have different flavors. And then, of course, you have video and other things. So I think basically I would say the modality is one dimension, and another is how fast or how quickly we can create kind of like new samples, and completely orthogonal. Maybe the direction is, or dimension is, how much control we have, right? So I think we kind of picked a specific direction or a specific vector in the space for Genie 3. I think different products, different models can try and go in a different direction. I think the space is pretty big, and there are a lot of trade-offs to be made. So I don't know. I think it really depends. Some people believe there is one model that will do everything, or I think it's still open-ended. What's the best way? Like we're in a place where engineering is a big part of our research, right? And actually making those, like, it's not a paper, right? Where we want to build something that people can actually use. So I think this really makes it like abstract ideas go to get you to some point, but to actually build things, you have to make some concrete decisions. And I think it kind of like forces you to decide what you want to do and what you're gonna.
Yeah, I think this is a really interesting point, Mike. And ultimately, it has to be driven by like technical decisions, and also like the goals, right? So if you look at the models right now, we obviously made a choice that we want VO3 and Genie 3 to be separate projects this year, right? And if you look at look at them both as they are right now, they have very different capabilities that the other model does not have. And technically, to combine all of that already into one model, right, would be, I think, very challenging to. I mean, VO3 is clearly a higher quality threshold than Genie 3, right? And it has very different priorities, right? So then the natural things you could say, oh well, what if we just took these together and combined them? But that may not be the best next step for either of those two models, right? So it may not be the case that the thing that the other one has is actually the most compelling thing for a completely different experience. And I think that given the breadth of interest in both models, right, there's actually quite a small set of people that are like really actively using both, and they tend to be more folks like yourselves who are just more broadly interested in AI, right, rather than like really downstream use cases. So like you mentioned agent training for one, which is like very sort of like high action frequency, requires more ecocentric sort of I guess more like worlds where tasks can be achieved, but doesn't require the like high quality cinema style videos you could generate with a BO model, right? It's quite different. And then on the filmmaking element, I mean, I'm not so sure that Genie 3 is really there at this point. And that would be necessarily the goal.
I don't know. On filmmaking, Justine can do some pretty incredible things with the filmmaking tools today. You'd be surprised.
Give me access and I will make amazing films with Genie 3. I guess that did kind of get to one of my questions though, which is the work you guys are doing is incredible, and you clearly probably have so much going on in your brains just to coordinate training these models and managing these teams. How much do you also have to think about like what are the downstream use cases of the model when you're training it? Because you could imagine a world in which you're just like, we don't really know or care what people are going to do with it yet. We're just going to go in the research direction we think we should go and see what happens. But based on how you guys are talking about it, it sounds like you've also been pretty thoughtful around what are the different capabilities or features needed for different potential use cases, at least, of different models.
Yeah, I'll say that basically we have some applications in mind, but that's not what's driving the research. It's more about how far can we push in this particular direction? Can we make all of that work like really great quality, really fast generation, real time, very controllable? I think that's kind of like what drives us. I think there to develop Genie 3, and the applications kind of like follow. And I don't think to be honest, I don't know what would be the applications for. Like I think we're very surprised. I like to mention like VO3. We all people find new ways how it can be useful, and to prompt it, we have like visual stuff. People just discovered it, right? We didn't even think about it initially. So I expect kind of the same thing, and I think that's why I am excited for more people to be able to access it in the future. And in general, our approach is to make sure that over time there is more access to the models we build, and I think that's the only way to discover what's the real potential.
I guess one somewhat related to that, like how do you think going forward, like Genie 4 or 5 or any other models, like what is like top of mind right now? Like if you wanted, for example, to focus on, I don't know, like seems like gaming could be one of the applications, having multiplayer type of games where you have two special memories, or two different completely views, but at some point they merge. How are you thinking on like going forward? Like what's next? Is it like scaling these models just on more data, more compute? Is it creating this sort of like multi-universe type of things where you have multiple players, multiple people looking at the same model but in different views? What's like top of mind for you guys?
Top of mind, I think for the next few days might be a vacation. After that, maybe walking my dog in the real world. And then I think you mentioned a bunch of really interesting things, to be honest. And like, I think we're still collecting a lot of feedback on this current model, right? And I think that in general, we are most interested in building just the most capable models, right? And so we would hope to have even broader impact in future, and really enable other teams to do cool things with it, right? Both internally and externally. And for me, it's like, I just started this with like a very, very focused vision about AGI. And I still think, honestly, what I'm excited about for AGI, and which is more embodied agents, I really believe this is the fastest path to getting these agents like in the real world. And I think we made a big step towards that. But I'm still like sometimes even more excited about applications I never thought of that come up from other people seeing the model, right? So I think it's kind of this like trade-off of, obviously you want to focus on some applications, but then you want to be open-minded about others. And I think that's the real joy of building models like this, right? Is you get to see all of these people who can be way more creative than me with it. So I think that there's like always really cool things that we can do. And I honestly can't really tell you in 1 year what the biggest application will be. But we'll definitely be trying to build better models.
Yeah, I'm really excited. But I think we are only as impressive, maybe the model is. I think they're very far from actually simulating the world accurately and being able to do, kind of put a person in there and then do whatever they want. And I mean, when I say far, it doesn't mean it's far in terms of calendar time, because we live in an accelerated timeline. But it feels like there is more work to do to get there. And I think I just imagine like once we can actually whatever the form factor would be, but step into this world and just kind of like maybe tell it how you want to what you want to experience. There's so many applications. Imagine, for example, someone is afraid of talking to people on a stage or in a podcast, right? They can simulate that, right? Or you can have someone who's like afraid of spiders. They can maybe actually see themselves getting over that. So that's like, just one example of something that's actually my wife thought about it. It's not my idea. So I think it's really like, there's so many things, right? So I think this is just, it all hinges on the ability to simulate the world and maybe put ourselves in it, maybe seeing ourselves from the side. And potentially having agents interacting with things, and yeah, the realism and really making it work in the way that is similar to our world, I think is really key.
I'm actually personally petrified of skiing, and the model's already quite good at that. So I might, when things quieten down, spend some time, because I promised my wife that our children would grow up knowing how to ski. And we're getting close to the age where I have to live up to my promise, and I'm not sure if I want to do it yet.
So we have to improve the model for you, Jack, so you can actually
get that in distribution.
I hope so.
We were just talking about before we started that we might see applications like in robotics. I mean, Jack, you were talking about embodied AI, and like now, like limitation in robotics is the data, right? Like how much data you can collect, and now probably you can just generate a lot of different scenes that you were not able to do before, purely from like just recording videos or so. So I think that's another thing that is pretty exciting. And I mean, congrats on the model. It's phenomenal.
On the robotics application, there was a conversation that I was listening to from Demis yesterday, where he was talking about your guys' work on Genie 3, and he mentioned that there's an agent, I think you guys call it Sima, right? Yeah. Which can then interact with the Genie agent. And as I was hearing him describe it, which was kind of breaking my mind, which is that you had one simulation agent asking the Genie agent to essentially create a real-time environment for it to interact in, right? Which was when I realized, the way you guys have built it, it's composable with other agents. Can you talk a little bit about why that's so important for robotics, like Marco was saying, and what are the major limitations today that you think we'd have to overcome as a space to make the robotics sort of progress, the rate of progress in robotics, much faster than it is now?
So we designed it to be an environment rather than an agent, right? So Genie 3 is very much like an environment model. Like we don't see it as like an agent itself that can like think and act in the world. It's more just a general purpose sort of simulator in a sense, right? That can actually simulate experiences for agents. And we know that like learning from experience is a really important paradigm for agents, right? That's how we got AlphaGo, because the agent AlphaGo learned by playing Go by itself, trying new things, right? And then learning from feedback with reinforcement learning to improve itself and actually discover new things. Like it discovered new moves like move 37 that humans didn't think was a worthwhile move, right? But actually AlphaGo learned that it was, because it could experience and try things for itself. And in robotics, we have this paradigm right now where there's some data-driven approaches, right? Where you can collect data in a quite laborious way, but it looks like the downstream task. So it looks real, and there's not so much of a mismatch between the two domains. or you can learn in simulation, right? But the robotic simulations are even the best ones, and we have some of the best ones at DeepMind. We have Majoko, right, which we work with. They're still quite far away from the real world, right? And so you have the sim to real gap. But even the sim to real gap itself, I think is kind of like poorly named, because what people consider to be real in robotics is typically still a lab or some very constrained environment where you've got a bunch of spotlights on a robot and then tons of researchers crowding around watching, whereas really real for me is, making any reference to this, it's the ability to walk my dog when I'm too busy, to hold the lead, cross the street, see someone who's scared of dogs, know to go around them, see someone with a ball, change directions, like all these challenging situations in the real world, right? And of course, you still have gripping, you still have these other tasks, but you need to really discover your own behaviors from your own experience, right? And doing that in physical embodied worlds is super challenging, because there's so many reasons why. Firstly, that could be expensive to collect data in those settings. You'd have to keep moving the robot back to where it started every time it doesn't do something right. And also it could be unsafe, right? So there's many reasons why we can't really do learning from experience in the physical world, right? So we do it in simulation. But really what we think with Genie 3 is it's the best of both, right? Because you're taking a real world data driven approach, right? But then you've got the ability to learn in simulation. So it kind of combines the good parts of each of those. And so that's why I think it could be super powerful. Not just for robotics example, but I really love this idea of having, when it rains in London a lot, not having to take my dog for the second walk would be great.
And as you can see, we built a model basically for Jack personal applications. That's what's driving the project. Is the point, yeah.
Well,
There's a
clearly,
lot
Jack.
of dog owners out there.
I was just saying, clearly, Jack, it's time to move to California.
Yeah.
That's the solution. Not
Less
a model.
rain.
Less lag.
I mean, I personally love California, but my wife's not convinced. Sorry.
We'll convince her.
Yeah, just to touch on, maybe a final point on the robots, kind of like robotics part. I think it's definitely, robotics means it is more than visual, right? Like we need to be able to, I think this is an important point. We can drive the decisions of the robot by looking around, but still it has to kind of like, do actuations, decide where to move, how to respond to the environment. So I think there are definitely some gaps, but still at the core of the problem, being able to reason about the environment. We think this is something that's the world models or general purpose world models such as Genie 3 can really help with, and maybe with future research we can actually bridge those gaps of physical kind of like understanding and actually getting physical responses from the world, which is a very interesting direction to explore.
One last question from my side. And I don't know if you can answer this, but is it going to become public? Like, can developers access it at some point, or is there like some sort of idea on this?
So as you can see, we are very excited about having more people accessing it. So we're definitely want to make it happen. There is no kind of like a concrete timeline at the moment, but I'm sure once we have more to share, we will do.
Awesome.
One of the things I've been thinking about a lot is we see sort of with every like modality, like, maybe first LLMs and then image and video and audio, there's like early kind of glimmers of something really exciting in a project or a research preview. And then there's like a ton of data and compute and researchers kind of poured at the problem. And you hopefully see this sort of like exponential progress till you eventually get to the point where like you're out of data or the improvements don't come as easily. I'm wondering for your thoughts, like where we are on sort of that curve for world models.
That's a really good question. I actually have a super hand wavy, somewhat swerving answer, right? And I think it's actually both. So I think the current capabilities are actually already quite compelling. And so you could make the case that like if what you wanted was a minutes of photorealistic any world generation with memory, that could actually be the end goal, right? And 2 or 3 years ago, I probably would have said that was a 5-year goal. And so at that point, if you just wanted to improve that, I think you probably end up with this maybe like, I think the jump from Genie 2 to Genie 3 was absolutely massive, and went from being like kind of a cool bit of research that was like showing signs of life, something that could already be very compelling. But I think there's a lot more that you can do with this. And Shlomi kind of referenced this to himself, right? Like, it's not the case that you're dropping yourself in the world, right? And like, it's like being in the real world, for example. It's actually quite different to that. When you do, take a minute to look away from the computer screen, it's quite a bit richer out there. And that's just for the real world. We also want this ability to generate completely new things, right? So I think we've got a huge gap to close, right? With the new capabilities that we want to add. But I think it's maybe a bit different to language models. Or actually, maybe it is similar to language models, but with language models, there's been like lots of new steps that have actually come on top, right? That maybe we didn't think were possible. We thought things were plateauing, and then a new idea came that made a significant change. And that has happened a couple of times in the past few years. So I think that there's a few more of those left for sure.
My final question for you guys is: are we living in a simulation?
Oh yeah, that's every interview has to finish. My thinking about that is actually, I thought about it a bit. I think that if we live in a simulation, my take is that it doesn't run on our current hardware because it's analog and not like, it's continuous. All of the observations are continuous, and there is nothing like. But maybe the quantum level is some limitation of our. You wanted to go philosophical, so you go. It's some kind of like a hardware limitation of the simulation we run on. So. Take it or leave it.
That's a great answer.
Clearly, there's a lot of work for the TPU team to do.
Yeah, maybe quantum computing will be running our actual simulation. So yeah.
That's a great place to wrap. Shlomi, Jack, thank you so much for coming on the podcast.
Thank you, guys.
Thanks,
you
guys.
for having us.